Assalamualaikum friends, welcome to my new video. It is related to the consolidation test. Consolidation test is the removal of the water from the welds by the sustained load such as building load. So it is a time dependent process. Most commonly take place in clay type materials. There are three types of consolidation. Immediate consolidation is when the load is transferred. So there is the arrangement of the particles. Primary consolidation is the expulsion of water from the voids due to the uh, load transfer completely to the uh, particles. Secondary consolidation is the arrangement of the particles after the primary consolidation. This most commonly happens in the organic type of material. So here we are discussing the 1D consolidation. Why it is called 1D consolidation? Because there is consolidation in only one direction, which is the y-axis. So this test involve volumetric changes, which is the basically governing factor in the design criteria. So if the compressibility or the settlement exceeds the limit, then your lifetime of the structure will be start reducing. So apparatus for that test required is the consolidation apparatus, which includes the two porous discs, top caps, screws, odometer cell, confining ring and ring assembly, two filter papers, balance, spatula, wash bottle, china dish and stopwatch. The procedure of the test involves it can both perform on disturbed and undisturbed samples. For undisturbed sample, you need to transfer the sample directly into the ring, extracted from the shell white tube. And for the disturbed sample, you need to prepare the sample as per the MTT/MC achieved from the Proctor test. So first of all, you need to note down the empty weight of the ring, then put the soil sample and also note the weight of ring from or weight of ring plus the soil sample, and then you need to put the soil sample into the odometer by putting the porous disc and filter paper both on bottom and top. Then you need to put uh, top cap on it, apply the seating load on it, and then you need to fill the odometer cell with water and leave it for 24 hours for sample saturation. There is three phases. One is the loading stage. This is the basically result showing for the loading stage. The initial weight is 25 kPa, which will be doubled every time up to 400 kPa, and the other column is the basically time we are recording by the stopwatch. So as you put 25 kPa, immediately you need to start the stopwatch and record the reading at all these interval for each loading. The second stage, this is the basically consolidation test conducted on several materials. You need to perform around 3 samples of the each sample of each clay type, soil type. This is the unloading stage in which your sample starts swelling. So going back to the previous sheets, you need to remove the 400 kPa to disk, so it move back to the 200 kPa. Then you need to remove the 200 disk, it goes back to 100, and then remove the 100 kPa, so it move back to the 50 kPa. So as there is the swelling, so there may be change in the void ratio also. This is the again loading stage, which we load from the 100 up to the 1600 kPa. So this is the basically important initial parameters you need to know. Height of the ring dia from which you find the volume of the ring. These are the two parameters obtained from the Proctor test, which are the MDT and OMC. This is the specific gravity of the soil, which is obtained from the picnometer test. This is the discount of the gauge. These are the all reading. Noted down that note down the mass of the ring plus the wet soil. It is basically uh, uh, obtained from after the test. You need to weight down this test, and then you need to uh, put the it is the basically wet weight of this sample. After the immediate test, you need, as you remove the sample from the odometer ring, then you need to weight it. This is this weight. Then you need to put the sample for the oven dry. So this is this wet weight after drying and the sample. So from each, this is the initial moisture content that is added at the start of test, and this is the moisture content at the end of test. Volume of solids can be found out by this formula mentioned here. So total initial void ratio can be found out by this formula. This is the final height, which can be found out by this formulas, and height of solid can be found out by volume of solids divided by the area of the cross-sectional area of the reef, as density of the soil is already known, which is 1 gram per centimeter cube. So these are the all readings. This is these are the all kPa loads. So this is in kPa, this is in kilogram per centimeter square. So at the start of each test, all readings are the 0. So this is the readings that are after 24 hours. So deformation change in thickness of specimen can be achieved by multiplying the deformation dial gauge reading multiplied by the least count of the gauge. Change in void ratio can be achieved by dividing the deformation height divided by the height of solids. Void ratio can be found out by initial void ratio minus change in the void ratio. This is the basically curve achieved from this test. So this is the basically compression index portion, which is obtained from the loading of the specimen. So here we are taking E1, E2 against P1, P2, which are these 2 points. So, and this is the basically the recompression or the swelling portion of the curve, which is obtained from the unloading of the sample. This is the formula used for finding this compression index, and similarly the swelling or recompression index formula is same, but we are using the void ratio of the uh, unloading stages. For example, in compression stages, we are using 100 and 200 from this portion, and for the compression or swelling we are using the values from this portion. This is the basically range of CC, which is from point 1 to point 8. So our CC is around 0.12. So another factor we can find out by this test is the pre-consolidation pressure. It is the basically the load sustained by the sample in the past, which can be found out by only drawing the loading stages, void ratio and pressure. So for example, you need to start from the curve starting point, so you need to draw a horizontal line, then you need to draw tangent to the curve, and then you need to draw an angle bisector, and then you need to uh, extend the straight portion back. So the point where the line touches the angle bisector, then you need to extend it to the pressure x-axis, and this is the basically the pre-consolidation pressure, which is around 160 kPa. And this is the also formula for finding the coefficient of the compressibility. So again we are taking E1 and E2 from 100 and 200, and similarly there is the formula for the ME, which can be found out by this formula. So the CV is the basically time rate required for sample to completely consolidate. Here we are only considering that our sample is only saturated 90% saturated. So this is the basically method of Taylor time square root method, in which we require the square root of the time, and other is the deformation reading. So this is the deformation reading along the y-axis and square root readings along the y-axis, and these are the all readings obtained from the tests. So here we are seeing that what is the HDR. HDR is basically H0, which is initial height minus the deformation height divided by 2. So HDR is find out from this formula. So here we need to draw a line from the starting of the curve, then we transfer that point to around 1.15 by multiplying with it, then you need to extend it back, so the point where it touches that line, black line, then you need to extend back. So this is the point of square root time, which is around 1.25. So for T90, as the square of 1.25 is 0.156. So this is the formula by which CV is find out. So for each KPI you need to find out the CV, and at the end you need to take average, and this will be the total coefficient of consolidation of that test. Thank you. Welcome to my channel, and subscribe my channel. Allah Hafiz.